Welcome to Shh, It's a Secret. And despite the shh being in the title and all the jokes that we've made thus far, if you have any questions along the way or comments or funny jokes, feel free to just holler at me and we'll go from there. So this particular session is, I guess, part of my unofficial quest to eliminate hard-coded secrets, which we are going to talk about in great detail today. Before we get started, I just want to say let's give a round of applause really quick for the sponsors and the organizers, whom without we wouldn't be here today, right? So if any of you are in the room, thank you. Thank you. So what are we talking about today, right? Besides, knowing that we're talking about secrets. And so let's apply some context to today's session. So we're going to start with some introductions. Who the heck is this guy standing on the stage in front of you guys? I'm going to show some bad examples because it's fun looking at bad examples of code. At least I think so, especially when it's my own code, right? So we're going to look at some bad examples, and then we're going to spend a good chunk of the session working with key vaults, key vault firewall, and then we'll get into some fun stuff with system account managed identities. I say some fun stuff with system account managed identities. That's not to say the stuff that comes before that is not fun, just FYI, right? So, and the other thing I want to mention here is secrets management is a very broad topic, as anyone who has attempted to do it knows. This session, we are focusing on getting secrets to and from our scripts. Now, there's a whole other litany of secrets protection that we could get into. We probably don't have time for. For example, we had a fantastic conversation in 407 yesterday with some folks on the PowerShell team about potential places where secrets can leak in PowerShell, right? Things like transcript logs. You do a transcript log with PowerShell, and then it gets put out to Event Viewer, and then it gets ingested into Splunk, and then once the secrets are in logs, good luck, right? They're in the logs at that point. Another example was PS Readline, which is a tool that kind of has its own history. So tools like that, you kind of have to watch out for secrets as well too. We're not going to get into that level of secrets management, but that's certainly something you guys can think about as you work on your own scripts and stuff. So again, we're focusing on getting secrets to and from our scripts, and that's the focus of today's session. So who am I? I'm Andy Syrewicze. My apologies on the LinkedIn URL here. You're going to have to spell the last name. I've got a friend who says that I should change that to Andy Sandwich because in elementary school, the kids couldn't pronounce my name. It's pronounced Syrewicze, which is way simpler than it looks. So everybody just called me Andy Sandwich, and there were 3 other Andys in the class too, right? So anyway, if you want to call me Andy Sandwich, that's fine. It works. But I've been in the industry for, 23 years now. And a good 18 years of that was spent doing infrastructure management. And then the last couple of years, I've gotten more into the security space. I'm currently a security evangelist for a security vendor called Hornet Security. And I'm also a Microsoft Cloud and Data Center Management MVP. Was originally a Hyper-V MVP. Any Hyper-V folks out there? Yes, I got some of my people here. You guys are awesome. Well, all of you are awesome, but especially to the Hyper-V folks. Anyway, but yeah, so I've been more in the security space now in the last couple of years, and making that switch kind of gives you some interesting context because you understand the pain points of the people in the infrastructure world, still managing cloud services, on-premises data center stuff, and now you have to put that security layer on top of it, and you understand the pain points of both sides, and that's kind of where the secrets management thing stems from. So, with that in mind, let's get to some bad examples. So when we talk about automated processes, right? When we are removing humans from the process of automation, what's wrong with this script? I don't have any candy or prizes to give out as, for answers, but brownie points, just for fun. Can anybody spot what the problem here is? Correct. Using get credential here. So forget about fully automated. This requires a human to be sitting in front of the machine, right? And ignore all of my terrible formatting here. I'm not great at formatting scripts, but it worked, for what I needed it to do. All right, how about this one? What's the problem with this script? Yeah, look at that. And not only once, it's in there 3 times. I wrote this script 8 years ago. So I can fall on my own sword for this one. In my defense, this was not for production. This was for a lab. Now, I still need to fall on my own sword, though, because of that whole concept, like, your lab should be an exact replica of production, and I should be doing those security things in the lab that I'm doing in my production, right? That whole thing. Anyway, yes, super secret password that no one will guess. Okay, let's get sneaky. What's wrong with this one from a security perspective? So close, but if you open up that file, so somebody got the bright idea, hey, I'm going to export a secure string to a text file and then ingest it later on. Correct. So a couple of issues with this, even if it's, secure string inside of this text file. One, if I'm a threat actor and I've compromised your network and I'm poking around your environment and I come across a file that says password.txt, I'm like, cool, sign me up, right? And so if I'm a threat actor, a text file is mobile, I just exfiltrate that off of your network and I can brute force that at my leisure. Or, and this is the thing that a lot of people don't think about when it comes to password files like this, if I'm a threat actor and I locate this and I know what it's for, I can use it just like you can. I can use it to authenticate to whatever it is it's protecting, just like you, the administrator, can, or the developer, or whoever, right? So these are the things that historically we did to try and get around this problem. And I'm still surprised, even to this day, how often I run into these 3 options. How many people out here in the last year have run into something like this? Okay. How many people in the last year have run into something like this that they wrote? Me too. Hence why it's in this slide deck. Anyway, so this has been a problem for a while now, right? And I think the other interesting insight that I got, again, in that talk we had in 407 yesterday, that kind of made me feel a little bit better about this, because I was putting this session together, I'm like, oh, this is really difficult, and there's a lot of bases that I have to cover with this, and this is a difficult problem, right? Managing secrets is very hard to do, because when we look at the business world, the company comes up with a business problem. Hey, go fix it now. Do it now. Right now. Right? And best practices sometimes go out the window in the face of let's just get it done and we'll secure it later. And surprise, a lot of organizations don't go back and have the operational maturity to fix it after the fact, right? Which is a problem. So, the problem. Attackers will take advantage of haphazardly stored passwords. So again, I've talked about my background here, being in the infrastructure space for a while, and then turning and pivoting into security. So the one thing I kept saying in sessions I was doing, in webinars and podcasts, I kept saying it over and over again. I'm really surprised that this threat actor thing, or this successful attack, I kept saying those words. I'm really surprised. You know what? I'm not surprised by things I see in terms of successful threat actor attacks anymore. I've gotten to the point to where I don't feel warm and fuzzy on private networks anymore, because we've been taught in the industry to assume breach. And it's true. It's absolutely true. And we should assume breach, because it's so easy for threat actors to gain a foothold inside of our environments, and then they start poking around for secrets. So, some examples. 2 examples here, but if you search the web, there's lots more. So the example on the left is from a CISA.gov CISA, CISA, CISA. I never know how to say it. Does anybody know? CISA? I always say CISA. Anyway. So I've kind of underlined the relevant parts here. So that left-hand one, discovered a PowerShell script containing plain text credentials that allowed them to escalate to admin. Yeah. So there's one. The one on the right, Uber suffered an attack in which an attacker gained access to critical systems using hard-coded admin credentials found in, again, a PowerShell script. So it's a problem. There's real-world examples out there of it happening in the wild, right? So we know it's a problem. So what do we need in terms of secrets management for PowerShell and automated processes, right? It needs to be stored securely. We need to be able to trust wherever we're storing these passwords is secure. Anybody here hear of KeePass? Yeah, it's a respected tool, right? I have one big problem with KeePass. It's a mobile file type, right? So I can remember a couple of stories I've heard where you have a team of engineers that are utilizing KeePass as a password repository. And either somebody gets let go or there's a disgruntled engineer and off goes that KeePass database, you know? It's mobile. So in terms of the file type itself being secure, yeah, I'd probably trust KeePass. Do I trust it to not be mobile? No. So that's where I come back to the whole securely stored. So we're going to be talking about Key Vault, but there's a number of other options out in the industry, right? You've got things like HashiCorp has HashiCorp Vault. You've got Thycotic Secret Server. You've got, I know Bitwarden has a CLI that integrates with their services. A lot of different options, right? You want it to be isolated within security boundaries. So we don't want plain text credentials traversing the public internet, right? Or if I'm authenticating a script that's running in Azure, for example, with another service in Azure, that password probably doesn't need to leave that resource group or that Azure data center region, right? So we want to make sure that we are isolating passwords within security boundaries. Needs to be monitored and reported. Reportable. I don't know how I want to say it. But you get the idea here, right? We need to be able to know when our password's being used, by who, when was it changed, by who, be able to report on that, not only from an operational perspective, but in the back of my mind, I always have things like incident response in my mind. If a threat actor ends up on my internal network and I see passwords being used all over the place that they aren't normally used, that's probably an indication for me, on top of a couple of other things. But we're seeing an increase in what's called living off the land style of attacks, which I don't know if everybody knows what that is. Living off the land is the concept where a threat actor ends up on an internal network and they use as many of the inbox native operating system tools possible to conduct their attacks, and the whole purpose is to avoid detection. So if I'm a network monitoring team and I see, oh, hey, PowerShell's running on the server over here, well, I'm used to seeing PowerShell, most likely, and so I'm probably not going to question it a whole lot. But if I see Mimikatz running on this system over here, like, okay, I got a problem, right? It raises a red flag instantly. So when we talk about that monitoring and reporting, we need to know what's going on with our secrets. And then it has to be protected from negligent and or malicious action. And when I say that, I'm thinking like the safety, like the, how do I want to say it? I have to make sure that level 1 help desk technicians are not unaliving password vaults. Let's put it that way, right? I want to make sure they're not accidentally deleting password vaults or maliciously if it's somebody that's, being let go or whatever. So those are a lot of, some of the core considerations when it comes to managing secrets. And that's why I like Azure Key Vault so much. And again, like I said, there's another number of different tools on the market that probably check all these check boxes. I'm just most familiar with Key Vault myself. And I wasn't going to create a fancy slide for this, but I fired up a new Key Vault in Azure, and I was looking at the page. This explains it directly. I just took a screenshot of the page. It just explains it perfectly. We control access to the Key Vault based on a number of different mechanisms. We have logging and alerts set up, and we have recovery options, right? And then I even like the very top. It's got some of the some of the best practice recommendations I've seen for a password vault product right here in the UI. The recommendation being, 1 vault per application per environment. So again, we talk about security boundaries. It's probably not best practice to put every single secret you use across your entire digital ecosystem into a single vault, right? It creates a lot of danger because if that 1 vault gets compromised, everything's compromised. So creating those different silos, those different security boundaries, again, assuming breach, helps protect us in that case. The blast radius won't be quite as large or quite as catastrophic, right? So I like Azure Key Vault because it checks a lot of these boxes. And so with that, let's show Azure Key Vault just a little bit here. And this is a PowerShell conference, so I'm going to spend most of my time in code here. So basically, this is not a script. This is basically just a demo walkthrough, right? And so at the beginning, I've got a number of different variables here that I'm going to go ahead and define. And I also have a function here that I'm going to get established here as well. Now, in terms of actually building Key Vault, you can automate this process if you want. If you don't have a resource group that you want to use already established, you can use new AZ resource group. You can use new AZ Key Vault here to actually spin up a new Key Vault, and that takes a second, so I'm actually going to run that. And so I'm using new AZ Key Vault. I've got the vault name that I want to use in the vault name variable. I've got my resource group defined in the variable and the resource group variable, and I've got where I want it in terms of Azure Data Center region inside of the Azure region variable. And what's nice about this is I say it takes a little time. It doesn't take long. It's like 20 seconds. But what's nice about this is when we're talking about automated processes, it's fast enough to where you can spin up new vaults on demand as needed fairly quickly. And there we go. It's done. So with that, if I scroll through here, the output a little bit, I can see a couple of key pieces of information here. I've got the vault name, and what I really want to highlight here is the vault URI. Now, when I get into the managed identities part of the talk here in a little bit, that vault URI becomes very important, and we'll actually have to use that later on. So, other couple of interesting pieces of information here that I'll expand on in a second. Soft delete enabled, true. So we talk about actually protecting the vault from negligent or malicious action. By default, Key Vaults in Azure have a soft delete turned on. And so soft delete, if it's actually deleted, it's soft deleted for 90 days. And then if you want protection over and above that, because as the administrator, I can still go in and delete that after it's been soft deleted, but there's something called purge protection. It's a tongue twister. You can see it's blank right now. By default, purge protection is not turned on. But the nice thing about purge protection, if I flip purge protection on for a Key Vault, not even admin can delete it until the 90 days have elapsed, or 120, or 160, or whatever you define. So not even admin can delete it if purge protection has been turned on. So we've got our vault, right? Let's return just a list of vaults. So if you want to see all the different vaults you have out there, you can return a list with get AZ Key Vault. The other thing I want to mention here, and this is optional, and I'm not going to run this because my test user is not a real user, but when you create a Key Vault, the user that created it is the one that has full access to the vault. You can also use RBAC, so Key Vault supports RBAC, which is really cool. But if you had to add an additional security principal, you could use the set AZ Key Vault access policy commandlet to do so. So that's kind of like the setup out of the way. So let's actually use this thing now, right? So if I want to actually place a secret in the vault, I can use convert to secure string. So the first thing I'm going to do is I'm going to capture the secret that I want inside of the secret value variable. So let's do that. And now I'm going to actually inject that secret into the vault. So I'm going to use set AZ Key Vault secret. I define the vault name here, and I'm going to name, what is this secret called inside of Key Vault? And then I'm going to pipe through the secret value that I've captured in the secret value variable. So I'll push that. It's already pushed it up into Key Vault, and it is there. Now, just like I can return a list of key vaults, I can do a list of secrets as well with get az key vault secret. Here's a list of all the secrets. We've only got one because it's a brand new vault. And more importantly, if I've got an automated process that I want to pull stuff down from Key Vault and store it inside of a variable, I can use get az key vault secret for that. So here I'm using that commandlet, defining the vault name, telling it what secret I want it to pull, and let's do that, and then we'll just write it to host. So you can see, there it is. My super secret password is password01 with an exclamation point. Now, that's just an example. What about some practical use? So what we need to do first is we've just pulled down the password, right? We need to actually build the PowerShell credential object so that we can pipe it through to a command, right? So I've got my secret value here. I'm going to grab that, make sure I've got it in the secret value variable, and now I'm going to use new object to actually create my credential object. So now credential is populated with a PowerShell credential object, right? And from there, what I've done here, this is just an example, but I'm actually using PowerShell Direct here to call a virtual machine that is running on this laptop, just as an example. Are you guys familiar with PowerShell Direct? No? PowerShell Direct is really cool. And this is where I get giddy with my Hyper-V background, and it kind of merges with PowerShell here, and it's really cool. So what PowerShell Direct is it's essentially PowerShell remoting over the Hyper-V VM bus. So you can do PowerShell remoting without having to touch the network, which is really cool because it's going across the virtual machine bus at the hypervisor layer. So it's really cool for things like deployment automations. So the bad example scripts I showed you earlier, that was part of a large script I had built that essentially used PowerShell Direct to basically automate the deployment of an entire virtualized data center. Like this script went out and it deployed a couple of virtual machines. It configured one as a domain controller, one as a file server. I think the third one was a SQL box. Anyway, PowerShell Direct, because there's not that requirement for the networking connection, allows you to do that kind of automation where it's traditionally problematic to do when you don't have a network connection. Anyway, I could go on about PowerShell Direct, and that's not what we're talking about today. But again, just using this as an example, we have captured, again, that credential out of Key Vault, and we are now going to use it for something practical, right? So I'm just going to, in this first example, I'm just going to use invoke command, and I'm going to query this WinServe 2022. And just for the folks that aren't familiar with PowerShell Direct, this -VM name parameter, this is what tells PowerShell you're going to use PowerShell Direct for this. That parameter is what tells PowerShell use PowerShell Direct. And then I just specify the VM name, and you can see I've got this VM running here on this box, WinServe 2022. It's a very original host name, right? Anyway, so let's run that. So we've captured the host name of that VM in this variable. Let's write it to host. There it is, WinServe 2022. Same thing. Let's say I want to get a list of processes. So here is a list of processes, and I've truncated it to 5. There they are. Of course, I could have formatted it a little bit better, but anyway, there they are. So that's just an example, right? So I could script all that if I wanted to. Now, did anybody notice so far in my examples one interesting thing? So if I scroll up here, when I am grabbing from Key Vault, this line, what's wrong with this line when we're talking about being secure? Plain text, exactly, in plain text. So that's a problem, right? In order, you can grab secrets as a secure string from Key Vault, but you have to use this module to do it here. So this module, you can install it, and it allows you to pull secrets from Key Vault as a secure string. I've not used this module myself because I use the managed identity method that I'm going to show here in a second. But I've heard from folks that it works really well. Anybody in here use this particular module? Thoughts? Works pretty well? Yeah. So anyway, it's there. I'm going to make sure I upload. Like I said, this is not a script, but at least walks through my demo. It's there in case you guys want the commandlet later on and you want to grab it. Anyway, so let's take it to the next step. There are times when you may be running some sort of automation where you need to generate a password, right? And so you can pair a function like I had up above with Key Vault in order to do some cool things around randomly generated passwords. So if I go look at this function, so I've got this function here, generate random password. So the user can input the length of password. The default is 12 in this particular case. I have a character set that I want it to pull from. And then I'm using -join to essentially go out and grab a random character from the character set as many times as the user defined with a default of 12 and smash it all together as a random password, right? Now, current thoughts in the industry would state that in order to have a sufficient amount of entropy on a password to be protected from current brute force attacks and fairly new future brute force attacks, you would need roughly a password of 20, 21, 22 characters. So if you have a password that is sufficiently random, you are truly selecting random characters with no discernible patterns, industry standards at this point in time would say that a password length of around 20, 21, 22 would be sufficient strength in order to fend off a brute force attack. So that's why I've got length of 22 in here. So let's run that. We're going to store that string in the random password variable. Return it to the console here, and you can see I've got my random string down here in the bottom left, right? So same thing, same process. Let's actually push that up into Key Vault. It's been put into the secret value variable. I'm going to push it up into Key Vault again. Return a list of known secrets. You guys have seen this stuff, so I'm kind of blowing through this second example. So now I've got two. I've got my super secret password, and I've got my super secret random password. And then same thing. I can retrieve it in the same manner that we talked about so far, right? So let me write that out, and we see, okay, I've captured the same value. So I've taken that random password, I've pushed it up into Key Vault, and I've pulled it back. And so you can kind of start piecing together, right, how this would work in an automated process, how you can leverage Key Vault for that. Now, if I want to remove Key Vault, I kind of mentioned this already. I can use the remove AZ Key Vault commandlet. It's like, hey, are you sure? Yes, I want to remove it. And then it goes into that soft deleted state, right? It's not actually gone yet. It's soft deleted. If I want to understand which vaults are in a soft deleted state, I can use get AZ Key Vault in removed state as a parameter, and it will show me what's in a removed state. And I mentioned if purge protection is not enabled, which is what this commandlet does here with the enable purge protection parameter. If purge protection is not enabled, I can, as the administrator, come in here, pass in removed state to remove AZ Key Vault, define my vault name, the region it's in, hit yes, and yes, that vault is gone forever at this point. Now, one other thing really quick worth noting, I've got to dig into a little bit further. The documentation for these vault removal commandlets actually wants you to pass the Azure region, not the Azure region, resource group. They want you to pass the Azure resource group to the command as well too. When I tried that, I got all kinds of errors. But as soon as I removed them, these commands worked completely fine. So I'm going to see if I can get a pull request in or at least clarify that. But anyway, with that, let's go back to, so that's the basics of working with Key Vault on the command line. Now, I have to put it back into slide mode, Andy. There we go. So that's cool and all, right? Who thinks it's cool? I think it's cool. I think it's cool. All right, good. We got a couple of hands. So that's cool, right? But we've accidentally created another problem. Does anybody know what it is? Yes, exactly. So I've got, Key Vault and my script talking to each other, pulling secrets back and forth. My script says, dude, give me those credentials. I need the creds, man. Give me the creds. Well, you need to authenticate first, right? And so now we have a chicken and egg situation. And, I wanted to put a picture of Obi-Wan here. You were supposed to solve the password issue, not create one, but alas, for copyright reasons. So yes, that is the problem. So how do we get around that? I'm going to show you managed identities here in a second, but there's some other things that we can do of varying degrees before we get to that. So maybe you're in a situation where you can't use managed identities for some reason, or maybe Key Vault is literally like the only thing in Azure you're using. There's a couple other ways that you can kind of secure this process while also passing credentials back and forth in the clear. It's not ideal, but it helps reduce that risk profile. I'm a big fan of just-in-time security because if a resource is, well, I guess, is everybody familiar with just-in-time? I would think so, right? A resource is only available absolutely when you need it, and it is not available at any other time. So I'm a really big fan of this because if a resource is not reachable, it can't be attacked, right? And so Key Vault Firewall allows you to do some of this stuff. So Key Vault Firewall, you can do things like, okay, I only want this virtual network in Azure to be able to reach this Key Vault, or I only want this Azure private link to be able to reach this Key Vault, or I only want this IP address or this IP range to be able to reach this Key Vault. And so now you can start doing things like, okay, I know that I've got automation kicking off at 10 p.m. At 9:55, I'm going to have an automated task in Azure run that configures Key Vault to now, configures Key Vault Firewall to allow the vault to be available to those IP addresses you specify, right? So the vault is only available from the external location or wherever you're running your script from when it's absolutely needed. Are you still sending passwords in the clear? Yes. If somebody gets a hold of those credentials and understands that it's for a Key Vault, can they then use those to reach into the Key Vault and get credentials themselves? Yes. But depending on what you're securing, you got to do that risk assessment, and maybe for some low, hanging fruit workloads that aren't really handling sensitive data, maybe it's okay, maybe. And that's where managed identity comes in. So managed identity, I could do a whole session on managed identity. So you're going to get the abridged version of managed identity. And when we look at managed identity in Entra, I keep wanting to say Azure AD, but it's Entra. What managed identity basically is we are going to take a security principle. In this case, I've got managed identities. I'm going to pair that with RBAC, and then I'm going to define a scope. In this case, in the example today, in this session, Key Vaults. So I'm going to take a security principle, I'm going to associate it with an RBAC group, and then I'm going to say the scope is Key Vault. Now, there's two kinds of managed identities you need to be aware of. My demo today uses system account managed identity. There's also user account managed identity, and I've seen the acronyms out there, SAMI and UAMI, I guess. But kind of reminds me of UFI. UFI, did anybody else call it UFI like I did? Yeah, okay, all right, I'm not the only weird one, all right. Anyway, the difference between these two, they're both setting up a security principle for you to use in this managed identity process. The big difference is system account managed identities are tied to a system. So in terms of life cycle, let's say I've got a VM in Azure that I've got a system account managed identity associated with it. When that VM in Azure is deleted, the managed identity object is deleted along with it. And that managed identity object can only ever be associated with that virtual machine. They're tied. User account managed identities can be associated with multiple things, and it has its own life cycle. So if I delete the object, the VM in this case that it's associated with, that user account managed identity hangs around out there, and I need to go delete that or do something with it after the fact, right? So in this particular demo, and I think this is really cool, because how many people have all of their automation existing solely within Azure? One? Okay, all right. That's what I expected. Usually people are running scripts on premises or in a hosted data center somewhere, in a colo or multiple clouds. It's rare for all of your stuff to be inside of just Azure. And so I was really happy when I learned that you can actually have an Arc-enabled server act with a system account managed identity. So Arc is the service in Azure that allows you to pull on-premises servers into Azure as a managed Azure object. And then you can assign a system account managed identity to it. So in my demo here, I have, again, my handy and very uniquely named WinServe 2022 VM sitting here. It has the Arc agent on it, and it is present inside of my Azure tenant as a Arc VM. So if I actually go look at Azure Arc, just so you guys know there's no smoke and mirrors here, there's my VM. So it is Azure Arc enabled. It's a on-premises VM running off of this laptop, right? But it's a manageable Azure resource now. So if I go back into my key vaults, and I've set aside a key vault specifically for this demo, I can configure access control so that that system, that VM, is trusted to access secrets inside of key vault without having to pass a password back and forth to it. So Azure Entra sees it as a trusted object, and you can go through a process where you get a token. The system can retrieve a token from Entra, and then I can use that token in subsequent commands to actually pull secrets out of Key Vault. So just to show you how this works, I would create a vault. The vault's already created in this case, but I would say I want to add a role assignment. And so I would come down here, and again, this is me creating the service principal side of a system account managed identity. If I was using the user account managed identity, I would have to go to managed identity in Azure and manually create that. But if it's a system account managed identity, I can do it right from here. So in this case, I've got a server that needs to, let's say, let me see here. I want it to, Key Vault Reader, for example, Key Vault Secrets User. It just needs to read secrets. It just needs to pull a password out of Key Vault and use it in some process, right? So I can configure this system account managed identity as a reader, basically. And then at this next stage, I can either choose an existing security principal, like a user group or service principal, right? Or I can choose the managed identity. And one second here, I forgot to hit select members. It's not a proper session if I don't mess up at least one demo, right? Anyway, so I've got my subscription here. I've got my managed identity. I've got a couple of options here. And I created a user assigned managed identity just so you could see it in here. If I wanted to use it, I could. But if I select Azure Arc here, you see my WinServe 2022. And I've already gone through this process for this demo, but if I finished this process out, it would establish that virtual machine as a trusted system to access this key vault. Now, that process is already taken care of. What does it actually look like to grab a secret? Now, this VM is just a server core box, so sorry, you have to stare at Notepad. But basically, what this script does is it goes out, it uses invoke web request, and I'm not going to go through every line. Where's my mouse? This is the problem with Notepad, is it hides the mouse. There we go. All right. Anyway, so basically what it does is it goes out and it grabs a token and it dumps it into this token variable. And what I've done is I've added this line down at the bottom where invoke rest method, and I'm actually using invoke rest method to take that token, prove to Azure Entra that I am who I say I am. And if you look at the HTTPS line here, remember that URI I mentioned earlier when the vault was created? Well, that's the URI for this particular vault. And so I'm telling invoke rest method, go out to this vault, and you see this Sammy demo password? That is the name of the secret that I want this invoke rest method to go out and grab. Now, if I go over here and actually run the script, there's the token, and then on the bottom right, here is the secret. The secret was obtained without having to pass a username and password through to Key Vault. So I established this virtual machine as a trusted entity as far as Entra is concerned, had it go out to Entra, grab a token, and then I use that token to go out and grab the credentials from Key Vault. Now, the inevitable question I always get here is, okay, what if Joe Schmo level 1 help desk person logs into that server? Can they access the vault? Absolutely. Because that system is allowed to access the vault. Now that's assuming that person understands how this process works, right? But the thing with security is it's not perfect from every angle, right? And that's where we come into the whole conversation around layered security. So remember I mentioned the Key Vault firewall portion earlier? I've seen organizations that pair these two processes. They pair managed identity with just-in-time access, right? So combined, having that vault only available when it absolutely needs to be, and then pairing it with something like managed identity is actually pretty strong security for most cases. Is it unbreakable from a really determined threat actor? Eh. But I always have to quote Steve Gibson here when I talk about this. He's a well-known security guy. It's part of the Security Now podcast, if anybody listens to it. But whenever he talks about that, he says something that makes me laugh. The only surefire way to share a secret between two people is to have them go out into the middle of a field, strip down naked, get underneath a blanket, and whisper into each other's ears. Probably true if you don't want anybody eavesdropping on you. But I would argue that the FBI or the NSA is probably in the bushes with a directional microphone. Anyway, so I have like 2 minutes left here, but I have lost my mouse cursor. Oh, there we go. Okay, back to my mouse cursor is seriously gone. I can see what it's highlighting though. There we go. Okay. So I talk about a lot of security topics like this. So it's a Hornet Security branded podcast. That said, I try really, 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 really hard to not mention product in it. I try for it to be entirely 100% value. For example, I just had Jan Bakker on. He's another MVP. We talked about passkeys. Really cool conversation. So looking forward to that. More conversations like that. But that's just an example. If you guys are interested, it's there. I've also included a bunch of resources in this slide deck. So you get a copy of this. I believe it'll be in the repo after the conference. But this is basically a list of all the stuff that you will need to do what I showed today. I also included a link to the two news items I mentioned earlier as well. With that, I know I'm at time. Any questions? I've explained everything okay, all right. So if you asked me 5 years ago, I'd be like, no, that'll never happen. They'll never brute force that. To answer the question today, and again, for the folks that didn't hear, you mentioned you use a certificate to, I forget exactly how you worded it.
It's Dave Wyatt put this module out years ago. It's called Protected Data.
Protected Data, okay.
Yeah, it does the same thing as export CLI XML, except you can provide
the certificate.
That way it can move between
So you can provide your own cert authority and provide a certificate. Now, okay, so the question is, how hard would it be to brute force, a certificate protected secret on your own? Well, you're not brute forcing it, but how protected is your secret in that situation? And like I said, 5 years ago, you asked me the question, I would have been like, no, they'll never brute force it. To answer the question today, after having been in the security space for a while now, it's not the attacks today that scare me. It's the future theoretical quantum computing brute forcing. Or as we've seen, the rise of GPU-enabled brute forcing. Can it be brute force today? Probably not. You're probably safe today. 2 years from now, you might want to revisit that. So it's just one of those things that you need to have in your annual process to review those things and be like, am I still safe? And do that risk assessment. If there are any further questions, I'm going to hang around for a bit, but you can always hit me up on LinkedIn. That's probably the easiest place to get a hold of me. But otherwise, thanks everyone. You guys have been great. Appreciate it. Please rate the session so I can come back next year. Next year, that's right. Thank you.